T-minus 3, 2, 1.
Atlas engine ignition.
Liftoff of the United Launch Alliance Delta IV Heavy rocket.
At Space Launch Complex 37, a Delta IV rocket is fueled and ready to launch the WGS-9 mission for the United States Air Force. Good evening, and welcome to Mission Control at Cape Canaveral Air Force Station in Florida. I'm your host, Mike Underhill. I'm a propulsion engineer at United Launch Alliance in our Human and Commercial Services organization. Tonight's 75-minute launch window opens at 7:44 p.m. Eastern Time, and our live mission coverage will continue through spacecraft separation, scheduled to occur about 42 minutes after liftoff. The launch count is currently in a planned 30-minute hold. There are 2 planned holds in our 9-hour launch count. The planned holds give the team time to conduct final systems checks and resolve outstanding issues prior to entering the terminal count. At this point, the team is not working any issues. Later in the broadcast, Lieutenant Dan Gunderson, a United States Air Force WGS test and integration engineer, will join me to discuss the WGS satellite, the United States Air Force, and more. I'll also be joined by Jason Lesh, the WGS ground system lead from satellite manufacturer Boeing. Stay tuned after launch because Lieutenant Gunderson and I will be hosting a game of trivia on Twitter, featuring questions about the Air Force's 70th anniversary. At 7:35 p.m. Eastern, questions will be posted to ULA's Twitter account, and the first person to comment on the question with the correct answer, along with the hashtag AF70, will receive a prize. Answers and winners will be announced shortly before spacecraft separation. Dave Kraft, the 45th Space Wing's weather officer, recently provided the final forecast. Today's weather is within the launch commit criteria. The probability of violating launch constraints is 0%, ground winds are 13 knots out of the south, and the temperature is 66 degrees Fahrenheit. So with that favorable forecast, we are proceeding towards a planned T0 of 7:44 p.m. Eastern. This is Delta Mission Control at T-minus 4 minutes and holding. Today's flight will deliver the 9th satellite in the Wideband Global SATCOM system. Built by Boeing Space and Intelligence Systems, WGS is an important element of a new high-capacity satellite communication system, providing enhanced communications capabilities to U.S. and allied warfighters for the next decade and beyond. Each WGS satellite provides more wideband communications capacity than the entire defense satellite communication system the constellation WGS is augmenting. For most missions, our customers provide artwork which is added to the payload fairing. For today's mission, the WGS-9 patch is uniquely designed to represent the equality of the partner nations participating in this mission. The 6 international partners include the United States, Luxembourg, Denmark, the Netherlands, New Zealand, and Canada. Today's flight will take a southeasterly heading away from our launch pad here at Cape Canaveral. Let's take a look at what else we can expect to see today.
The following profile details the important events of this mission using approximate times.
5, 4, we have engine ignition, 2, 1, and liftoff of the United Launch Alliance Delta IV rocket.
The Delta IV RS-68A main engine and 4 strap-on solid rocket motors ignite to lift the vehicle away from the pad. Shortly after liftoff, Delta IV begins its initial pitch and yaw maneuvers to attain the proper ascent profile and minimize aerodynamic loads. Delta IV reaches Mach 1, the speed of sound, at 34 seconds. At 46 seconds, the vehicle reaches maximum dynamic pressure. The strap-on solid rocket motors, or SRMs, burn out approximately 93 seconds into flight. At 1 minute, 40 seconds, the first 2 SRMs are jettisoned. Approximately 2 seconds later, the remaining 2 solid rocket motors are jettisoned. The payload fairing is jettisoned at 3 minutes, 15 seconds. Approaching booster engine cutoff, the Delta IV is burning propellant at a rate of approximately 995 pounds per second, flying at more than 111 miles in altitude and 225 miles downrange. Booster engine cutoff occurs just under 4 minutes into the flight. 7 seconds after booster engine cutoff, the first stage is jettisoned. Second stage main engine ignition takes place at 4 minutes, 16 seconds into the flight. The second stage and WGS satellite are now in the first burn. Following the first second stage main engine cutoff at approximately 20 minutes, the mission enters a coast phase. At 29.5 minutes into flight, the second stage main engine is reignited for a 3-minute burn. Following cutoff, the second stage and payload enter a coast period in preparation for spacecraft separation. At 41 minutes 46 seconds, the second stage releases the Wideband Global SATCOM satellite for the United States Air Force.
Base bending moment, instrumentation is active and data is valid.
BBM is fully mission capable and recommend placard 6 alpha for launch.
ALC, verify wind monitoring system is set.
The Delta IV Medium Plus 5.4 includes a common booster core powered by an Aerojet Rocketdyne RS-68A engine and 4 orbital ATK solid rocket motors. An Aerojet Rocketdyne RL-10B2 engine powers the Delta cryogenic second stage. WGS-9 is protected during ascent by a 5-meter diameter payload fairing. Final launch preparations began on February 14th when WGS-9 was encapsulated inside the payload fairing. On February 24th, the encapsulated payload fairing was transported to the Mobile Service Tower, or MST, at Space Launch Complex 37 and mated to the Delta IV rocket. Approximately 9.5 hours ago, final preparations began at Space Launch Complex 37 using 40 hydraulic cylinders at pressures nearing 3,500 psi. The 10 million pound MST was raised 8 inches and rolled back, revealing the Delta IV launch vehicle. Using a carriage transporter system, traveling at about a quarter mile per hour, it takes about 25 minutes to roll the MST to its launch position 345 feet north of the Delta IV rocket. The Delta IV rocket stands 217 feet tall, or about 21 stories, and weighs more than 900,000 pounds fully fueled. The RS-68A main engine and 4 solid rocket motors combine to produce approximately 1.7 million pounds of thrust at liftoff. About 4 minutes later, at stage separation, it weighs just 10% of what it did at liftoff.
Modifications are complete.
Roger. MICO, initiate data logger just prior to the LSAT.
We partner with the Air Force's 5th Space Launch Squadron to launch our Cape Canaveral missions. Earlier this morning, I was out at the pad during MST roll and had a chance to speak with the 5th SLS's Lieutenant Chuck Hohenbaum. Lieutenant, what's your role in providing mission assurance for today's WGS-9 launch?
Our role at the 5th Space Launch Squadron is to provide an independent technical risk assessment of the launch vehicle's health and capability for the Air Force.
That's great. And what specifically is your role at the pad this morning?
This morning, myself and one of our enlisted technicians are out here, essentially adding an extra set of eyes and ears during the roll of the Mobile Service Tower. We'll be looking for any clearance issues and helping troubleshoot any issues that might arise.
I'm really looking forward to this evening's launch. Where will you be and what are your responsibilities during launch?
During the launch, I'll be sitting in the Air Force's Primary Operations Center here on the Cape. Specifically, I monitor the ground systems here, making sure that they're ready to support the vehicle. I help troubleshoot any anomalies that might arise and provide concurrence for critical operations.
Well, thanks for joining me and good luck this evening.
Thank you, sir.
Before today's launch, let's take a look at the amazing upgrades WGS has made to improve military communications around the world.
While Boeing engineers build the next wideband global SATCOM satellites, the first satellites currently on orbit are providing global communication for the Department of Defense.
It offers over 3.4 gigabits of information throughput. This system actually operates in the Ka and X bands, which is critical for communicating with various armed services.
Another important advantage the WGS satellite provides to armed forces across the globe is anti-jamming capability in parts of the world known as highly contested areas.
WGS has the ability to shape some of its beams to a specific communications area on the globe. So whether it be a shipping lane or whether it be around land masses, it also has the ability to move and pivot its communications beams to be able to follow communications users or to avoid jamming.
WGS satellites allow increased global cross-communication for all branches of the U.S. Armed Forces serving military missions or humanitarian relief efforts on land, in the air, and at sea. And now, thanks to a program created by the Department of Defense, the WGS satellite system has been expanded to partner nations.
The 6th satellite was actually funded by the Commonwealth of Australia, and the 9th satellite was funded through a consortium of 5 different member nations: Canada, New Zealand, Luxembourg, the Netherlands, and Denmark.
Bringing our partners into our programs together and building these relationships and building these systems together really solidifies interoperability. So now we're using the same system, we're using similar terminals, we're able to communicate better across the battlefield.
Access to the WGS system offers partner nations not only increased communications capability in the field, but convenience in their budget.
They can put in only what they need in terms of buying into the system, and then they get global access through the entire constellation. It allows them to buy in without investing in the infrastructure, which includes the launch costs and the mission commanding and control.
There's an incredible amount of pride to be able to take this and build this communications satellite and provide this capability to the DoD and its allied partners.
This is Delta Mission Control at T-minus 4 minutes and holding. We remain in the planned 30-minute built-in hold as preparations for the launch continue. In a few moments, launch conductor Ed Kidda will pull the launch team for the final go to pick up the countdown. 32 engineers and managers are pulled for system status and readiness to proceed. This is the final status check before launch for all Delta vehicle systems, ground systems, the spacecraft, and the U.S. Air Force Eastern Range.
HYE.
Go.
LOX 1.
Go.
LOX 2.
Go.
VP.
Go.
P&E.
Go.
BP.
Go.
ATC 1.
Go.
PEA.
Go.
Fuel 1.
Go.
Fuel 2.
Go.
TM 1.
Go.
ATC 3.
Go.
TM 2.
Go.
FMA.
Go.
VE.
Go.
EEA.
Go.
GE.
Go.
SYS.
Go.
DSE.
Go.
Timer.
Go.
ECS.
Go.
QE.
Go.
USO.
Go.
OSM.
Go.
VSE.
VSE is go.
ALC.
Go.
AC.
AC is go.
RC.
Clear to proceed.
LD.
This is the launch director, and launch vehicle is ready to launch.
MD.
The CMD, you have permission to launch.
Proceeding with the count. MEQ established swing arm lock pins pull.
Active.
SYS established record on change list activated.
Activated.
Polling is complete, and the launch team has given the go for launch. The countdown will resume approximately 2 minutes from now. At T-minus 4 minutes and counting, the team will enter the terminal count and will begin securing the second stage liquid oxygen tank. At T-minus 3 minutes, 32 seconds, booster liquid hydrogen and liquid oxygen tank securing is started, which includes closing the propellant fill and drain valves. Also at T-minus 3 minutes 32 seconds, vehicle transfer from ground facility power to its own internal battery power will be complete. At T-minus 3 minutes, the vehicle ordnance system will be armed, and booster liquid oxygen and liquid hydrogen propellant tanks are verified to be at flight pressure and flight level. At 2 minutes prior to liftoff, the team will verify that the hydraulic system is pressurized, as well as confirm booster, DCSS, and flight termination system battery voltages. At T-minus 1 minute 20 seconds, the team will begin securing the second stage liquid hydrogen tank. At T-minus 60 seconds, the eastern range of readiness is verified. At T-minus 50 seconds, the DCSS liquid hydrogen tank is secured at flight level. A final launch vehicle and spacecraft status check is conducted at T-minus 30 seconds. At T-minus 15 seconds, the ROFIs, or sparklers, are ignited to burn off excess hydrogen at the base of the vehicle. Liftoff will occur at T0. After liftoff, we'll hear the voice of Patrick Moore providing launch vehicle ascent data.
Permission to reinstall pins.
Proceed.
This is Delta Mission Control at T-minus 4 minutes and holding. The planned hold has been extended due to an alarm related to the swing arm system. We'll pass on information as it is received. This is Delta Mission Control at T-minus 4 minutes and holding. This is Delta Mission Control at T-minus 4 minutes and holding. The launch team is still looking into the issue. We expect an updated report in a few minutes. We'll pass on more information as it is received. This is Delta Mission Control at T-minus 4 minutes and holding. Our engineers continue to investigate a ground issue. Today's window does extend until 8:59 p.m., allowing the launch team some time to investigate. We'll pass on more information as it is received. This is Delta Mission Control at T-minus 4 minutes and holding. Our engineers continue to work in a ground system issue. Today's window does extend until 8:59 p.m. Eastern Time. We'll pass on additional information as it is received. This is Delta Mission Control at T-minus 4 minutes and holding. The planned hold continues to be extended as engineers continue to work a ground system issue. Today's window does extend until 8:59 p.m. Eastern Time. We'll pass on more information as it is received.
LC, there's ACM1. I'm ready to outbreathe the swim armor fault.
Roger. LD?
LD.
MD?
MD.
Proceed, AC.
All right, the team evaluated the data available on the swing arm controlling laptop. We saw no evidence or any issue with the swing arms themselves. The team recommended troubleshooting of proceeding with re-pulling the pins and evaluating through the reset of that system. Pins were pulled properly, no alarm, and reset was proper. Final evaluation of the data on the laptop shows a healthy system. There's no further interaction. At this point, we were ready to pick up with basically an L7 area and with pins already pulled. Recommend proceeding.
LC copies and concurs. Launch Director?
LD concurs.
Mission Director?
MD concurs.
This is Delta Mission Control at T-minus 4 minutes and holding. The launch team has resolved the issue and is working to establish a new T0. We should have an update in just a few minutes.
Enter tank temp to 90 degrees.
Roger.
LC, LD channel 1.
Go ahead.
LC, at this time, please establish a new T0 of 00:18:00 Zulu.
Roger. RCLC?
RC.
Please coordinate a new T0 with a range of 00:18:00.
Understand 00:18:00 Zulu in coordination.
Timer LC?
Go ahead.
Please set the countdown clock to a new T0 of 00:18:00.
Work.
ALC, hold fire off.
Hold fire normal.
LC timer.
Go ahead.
Picking up about 8 seconds.
Roger.
This is Delta Mission Control at T-minus 4 minutes and holding. The launch team has resolved the issue and established a new T0 for 8:18 p.m. Eastern Time.
CNET 1.
Go ahead.
Range is approved. New T0 00:18:00 Zulu.
Roger.
Master script running.
Roger.
L minus 7 minutes.
This is the LC on net 1, performing status check to proceed with terminal count. MEQ.
Go.
MEA.
Go.
HYE.
Go.
LOX 1.
Go.
LOX 2.
Go.
VP.
Go.
P&E.
Go.
BP.
Go.
ATC 1.
Go.
PA. PA net 1.
Go.
Fuel 1.
Go.
Fuel 2.
Go.
TM 1.
Go.
ATC 3.
Go.
TM 2.
Go.
FMA.
Go.
VE.
Go.
EEA.
Go.
GE.
Go.
SYS.
Go.
DSE.
Go.
Timer.
Go.
ECS.
Go.
QE.
Go.
USO.
Go.
OSM.
Go.
VSE.
VSE is go.
ALC.
Go.
AC.
AC is go.
RC.
Clear to proceed.
LD.
This is the launch director. The launch vehicle is ready to launch.
MD.
This is the mission director. You have permission to launch.
Proceed with the count. SYS. Establish record on change list. Activated.
Activated.
Launch team polling is complete.
L minus 5 minutes.
MEQ report swing arm system ready.
Ready.
FC verify spacecraft is configured for launch.
Spacecraft configured for launch.
All steps are complete prior to terminal count.
We anticipate releasing the hold in just a few moments.
T minus 4 minutes and counting.
Upper stage lock securing started.
Vehicle transferring internal.
3 minutes 50 seconds.
The countdown clock has resumed, and we are go for launch at 8:18 p.m. Eastern.
Pellet securing started.
Vehicle transfer internal complete. CBC LH2 secured.
CBC lock secured. CBC pre-press started.
Upper stage lock secure at flight level.
T minus 3 minutes.
Vehicle ordnance arming.
CBC locks at flight pressure and flight level.
Vehicle ordnance armed. CBC LH2 flight pressure and flight level.
T-minus 2 minutes.
TPA script running.
Hydraulic press at 4,000.
T-minus 90 seconds. The launch vehicle, payload, ground systems, and eastern range are go for launch.
1 minute 20 seconds.
Upper stage, LH2 securing started.
1 minute 10 seconds.
T-minus 1 minute.
Go. Rock report range status.
Range green.
T-minus 50 seconds. Upper stage LH2 secure at flight level. 45.
Launch enable. GE main power off.
Main power off.
T-minus 30.
Status check. Go Delta. Go WGS-9. Green board.
25.
Light locket.
SRM TVC blowdown.
15.
Rough ignition.
T-minus 10, 9, 8, 7, 6, 5, 4. RS-68A engine ignition. 1. And we have liftoff of the United Launch Alliance Delta IV rocket carrying the WGS-9 mission for the United States Air Force. What a great way to celebrate the Air Force's 70th birthday.
At full thrust. SRM burn profile is also looking good. 20 seconds into flight. SRM chamber pressure is beginning to tail off of max pressure. 30 seconds in.
You are hearing the voice of Patrick Moore providing launch
Mach
vehicle
1
ascent
Delta 4
data.
is now supersonic. Now passing 46 seconds, max Q, maximum dynamic pressure. Vehicle traveling right down the middle of the range track, looking good. RS-68 engine operating parameters continue to look good. Now passing 1 minute into flight, approximately 30 seconds remaining in the solid rocket motor burn. SRM burn profiles continue to look good. Vehicle traveling right down the middle of the range track. Delta IV is now 14 miles in altitude, 32 miles downrange, traveling at 2,200 miles per hour. Standing by for SRM burnout shortly. And we have SRM burnout standing by for solid rocket motor jettison. We have good indication of jettison of all 4 solid rocket motors. 1 minute, 50 seconds into flight. Delta IV rocket now weighs just 1/2 of what it did at launch, burning propellant at a rate of almost 2,000 pounds per second. Upper stage ACS press valve has been opened. ACS tank is now pressurizing to flight levels. Vehicle now passing Mach 5. Delta IV is now 39 miles in altitude, 90 miles downrange distance, traveling at almost 4,000 miles per hour. 2 minutes, 15 seconds into flight. RS-68 continues to perform well. Fuel injector and chamber pressures look good. Now passing 2 minutes, 30 seconds into flight. Vehicle continuing to travel right down the middle of the range track. Upper stage lock system has begun the boost phase chill down sequence to begin thermal conditioning of the RL-10 engine. 1 minute to BECO. Now passing 3 minutes into flight, Mach 10. And we've begun the upper stage boost phase chill down for the LH2 system, standing by for payload fairing jettison. And we have good indication of payload fairing jettison. RS-68 continues to perform well. Fuel injector and chamber pressures look good. 3 minutes, 30 seconds into flight. The vehicle guidance system has stopped active guidance in preparation for MICO. Standing by for booster throttle down shortly. And the booster has begun to throttle down in preparation for MICO. And we have MICO booster engine cutoff standing by for stage separation. We have good indication of stage separation. Heads is deploying. We have pre-start. Ignition and full thrust on the RL-10. Vehicle body rate stamping out nicely from initial startup transients. This is the first of 3 planned burns for today's mission. This first burn should last approximately 15 minutes and 30 seconds.
This is Delta Mission Control at T plus 4 minutes, 41 seconds. We've just heard Patrick Moore report the successful execution of the early events of tonight's flight, and all systems continue to operate nominally. The Delta IV second stage and WGS satellite are traveling over the Atlantic Ocean in a southeasterly direction away from the coast of Florida. The mission is now in the first of 2 planned RL-10 engine burns. This burn will last approximately 16 minutes. I'm joined now by Lieutenant Dan Gunderson. Lieutenant, thanks for joining us.
Thanks for having me.
This year marks the 70th anniversary of the Air Force, is that correct?
That is correct. So in 1947, the Air Force was created as an independent service with the signing of the National Security Act. Since then, the Air Force has drastically evolved, oftentimes by challenging conventional wisdom to make great strides in technology and capability. This year, we celebrate 7 decades of innovating, breaking barriers, and providing America with global vigilance, reach, and power.
It's really an impressive legacy. So can you give us a top-level overview of WGS?
Sure. WGS is a military communications satellite that provides tactical communications to our warfighters.
So if we take a quick look at the WGS-9 logo, I think we'll see that there's a series of flags there. Can you tell us, does that represent our international partners?
That's correct. So this flag and the logos, this logo and the flags on it represent a significant achievement in U.S. international relations. In 2012, the United States signed a multilateral memorandum of understanding with Canada, Denmark, Luxembourg, the Netherlands, and New Zealand, in which they all agreed to fund the procurement of this satellite, WGS-9. In 2007, we had a similar arrangement with Australia, in which they provided the funding to bring the constellation to 6 satellites. In exchange for their contribution, each country receives a proportional share of the WGS constellation bandwidth, which provides a significant amount of communications capability.
It's really great to see us be able to partner with our allies in such a meaningful way.
Mm-hmm.
Can you give us a top-level overview of satellite communications?
Sure. So RF communications require line of sight. So if I wanted to get a message to another user that is over the horizon, I need to relay that message off a communication satellite first. Now, granted, that's drastically simplified But the WGS satellite has some of the most sophisticated technology that enables this process to happen at incredible speeds.
So that talks about some of the WGS capabilities. Can you tell us a little bit more about the WGS-9 satellite itself?
Sure. So each WGS satellite has more bandwidth and capability than the entire Discus system that came before it. WGS is also the only military satellite that has the ability to simultaneously utilize Ka band and X band and cross-link the two. So that means that users on different frequency bands can seamlessly communicate. Additionally, WGS has the capability to reposition itself on orbit and point its communication beams, which allows a great amount of flexibility to our forces and international partners if some sort of contingency had to be executed.
That's really impressive. So what is your role with regard to WGS?
So my role primarily pertains to test and integration. Leading up to the launch, which we just saw, I provide mission assurance in prepping the satellite, and then in the following months, I make sure that the satellite gets to its slot in the geo belt. Now, once it gets up to the geo belt, there are some rigorous tests that we have to run to make sure that the systems are performing up to spec. Once it's validated, the satellite is then repositioned to its location and where it can be used by the operational forces and our international partners.
Test and integration is a vital function for both satellite programs and launch vehicle programs, so it's really great that you're able to contribute in such a meaningful way.
Thank you. Yes, it is. It's very rewarding work.
So thanks so much for your time. Don't go anywhere because I'm going to get your help answering some of our trivia questions shortly before spacecraft separation.
All right, sounds good.
Now passing 10 minutes, 30 seconds into flight. The Delta IV is now 270 miles in altitude. It's 1,750 miles downrange distance, traveling at 12,500 miles per hour. Vehicle trajectory continues right down the middle of the range track. RL-10 engine operating parameters remaining nominal. Now passing 12 minutes into flight, upper stage systems continue to remain nominal. LH2 and LOX tank pressures looking good. ACS thruster firings continuing periodically as expected. Upper stage ACS tank pressure remaining stable, vehicle body rates remaining stable as well. RL-10 engine operating parameters remaining nominal. Trajectory remains right down the middle of the range track as expected. Delta IV is now 260 miles in altitude, 2,200 miles downrange distance, traveling at 13,700 miles per hour. And the upper stage has begun the 4S settling on the ACS system as expected. Now passing 13 minutes into flight.
This is Delta Mission Control at T plus 13 minutes, 7 seconds. We're approaching the end of the first of 2 planned RL-10 second stage engine burns. The Delta IV and WGS satellite are flying over the Atlantic Ocean off the west coast of Africa. Our next event, the first main engine cutoff, or MICO 1, is scheduled to take place just about 4 minutes from now. While we wait for the next mission event, let's take a look at a video highlighting the anti-jam technology implemented in WGS-9.
Virtually every military mission relies on satellite communications. From data gathered by UAVs to teleconferencing between military leaders, WGS is the backbone of our military's ability to communicate. One satellite by itself can't service the entire globe, so it's really important to have an entire network of satellites to make sure that we have full coverage. WGS is the satellite network used by the military and our allies to communicate across the world, anytime, anywhere. We want to protect the satellite as much as we can, so WGS is going through a fleet-wide upgrade right now by uploading new software and modifying the ground segment to allow continuous communications that aren't interfered with. One of the major things that the military has been looking into is how to make satellites more resilient to jamming. Sources of jamming can range from an adversary that's trying to affect your communications path to someone who is accidentally in that bandwidth. One of the enabling technologies for anti-jam capabilities is the use of phased array antennas. By adjusting the power and timing of each of the antenna elements, we're able to create a shapeable beam to avoid the jammer that allows for warfighters to stay connected wherever they're located. When you take into account satellites that allow upgrades through software and the ability to provide anti-jam protection, it all allows us to provide a more resilient system that the military can count on.
Approximately 4 minutes remaining in this first burn. The Delta IV is now 200 miles in altitude, 3,000 miles downrange distance, traveling at 16,000 miles per hour. Vehicle continues right down the middle of the range track. RL-10 engine operating parameters continue to look good. ACS thruster firing continuing as expected. ACS tank pressures remain stable. LH2 and LOX tank pressures also remaining stable. Vehicle body rates remain very low as expected for this phase of flight. Now passing 16 minutes, 45 seconds into flight, approximately 3 minutes remaining in the first burn. Now passing 17 minutes, 30 seconds into flight. RL-10 continues to perform well in this first burn. Engine operating parameters all remain nominal. Launch vehicle trajectory continues to look good. ACS thruster firings continuing periodically as planned. ACS tank pressures remaining stable. Delta IV is now 155 miles in altitude, 3,600 miles downrange distance, traveling at 18,000 miles per hour. Now passing 18 minutes, 5 seconds into flight.
This is Delta Mission Control at T plus 18 minutes, 15 seconds. The Delta IV rocket carrying the WGS-9 satellite lifted off from Space Launch Complex 37 at 8:18 p.m. Eastern Time. We're now approximately 2 minutes away from completion of the first of 2 planned RL-10 engine burns. The mission will then enter a 10-minute coast period, followed by restart of the RL-10 engine. Let's join Patrick Moore for mission progress.
Approximately 1 minute remaining in the first burn. RL-10 continues to perform well. Engine operating parameters remain nominal. "19 minutes into flight. Now passing 19.5 minutes into flight, standing by for MICO 1 shortly. And we have MICO. Second stage engine is cut off. Vehicle body rates have damped out nicely after the cutoff transients. ACS thruster firings are continuing as planned.
We just heard Patrick Moore announce the successful completion of MICO 1. Joining me now is Jason Leish from satellite manufacturer Boeing. Jason, thanks for being here today.
That's my pleasure. Thanks for having me.
So what is your role at Boeing and with WGS?
So currently, I am a ground systems integrated product team lead. I've actually been on WGS for over 15 years, and I've had quite a few roles on the program in that time. But mostly I've been a payload systems engineer, supporting the development of various payload components and subsystems, and a ground systems engineer, helping to develop and deploy the payload control system.
So we heard Lieutenant Gunderson talk a little bit about the secure communications that WGS delivers. How does Boeing design and build each of the WGS spacecraft to ensure these capabilities?
Well, it starts with the mission. So in the case of WGS, the mission is to provide secure, high bandwidth communications for our warfighters. Once we understand what the mission is, we write requirements that specify at the system, subsystem, and component level exactly how the spacecraft is supposed to work. Once we have requirements defined, then we can come up with a design that satisfies those requirements. Then we build it and do a lot of integrating and extensive testing throughout.
So can you expand on that a little bit? How do you build and test WGS spacecraft?
So we do all the engineering in the Boeing Satellite Development Center in El Segundo, California, which is one of the largest satellite manufacturing facilities in the world. And everything is done there, from the requirements definition to the design. We manufacture many components. We do all the integration and testing there. We have a number of specialized test facilities there to simulate some of the environments that you see both in orbit and during launch. Once it's all tested, we load it on a Boeing C-17, fly it to Florida, do some more testing, and to verify that it's ready for encapsulation and launch.
So that gets the spacecraft processing, gets us to launch. What about the ground side? That's a critical element. Can you expand a little bit on the other support that Boeing provides?
Sure. So there's actually 2 ground systems that we use to control WGS on orbit. The first one is primarily used for platform control or flying the satellite, and this involves keeping it in its orbital slot, keeping it pointed at the Earth, moving it if necessary. The other system is for payload control, and that involves configuring the payload for specific user needs, such as maybe moving an antenna to cover a particular user, routing that user using the channelizer, configuring some additional parameters to optimize performance, things like that.
So Boeing has over 50 years of experience developing both government and commercial satellites. Can you expand on some of the details that make WGS spacecraft unique?
Yes, there's a couple of technologies actually that are pretty interesting when it comes to WGS. The first one of those is the channelizer, which is basically a big digital switch that allows us to connect any uplink to any downlink, and that means that you can be operating at any frequency and in any beam and trying to transmit to a different frequency and a different beam, and you can connect those things using the channelizer. So it's a pretty amazing capability. The second really interesting technology is the phased array antenna, which you heard about in the anti-gem video a minute ago. And the phased array is a fixed antenna, but it's made up of a number of smaller antennas, basically, or horns, and that allows us a high degree of control over the size and shape and performance of the beam. That technology is what allows us to implement a lot of those anti-jam capabilities. Of course, the most recognizable feature of the satellite is probably the solar wings, and WGS-9 has some new solar cells compared to WGS-1 through 8. They're about 30% larger than the solar cells we used previously, and Spectrolab did a great job. Not only were they able to make the solar cells larger, but they were more efficient as well. This allows us to put fewer of them on the solar wings, reducing weight, but also increasing power at the same time.
That's really amazing. Thanks for sharing all that great information, and thanks for joining me here today.
No problem. Happy to be here.
Let's return to Patrick Moore for our upcoming mission event.
Approximately 4 minutes remaining now until MES 2. In approximately 3.5 minutes, the second stage engine will ignite to begin the second of 3 burns for today's mission. 20 seconds prior to ignition, the RL-10 will begin the fuel and oxidizer pre-start sequence. This burn should last approximately 3 minutes. Following shutdown of the engine, the Delta IV will enter a 9-minute coast duration prior to spacecraft separation. Two and a half minutes remaining in this first coast period. Upper stage systems continue to look good in the coast period. LOX and LH2 tank pressures remain stable. Helium bottle and ACS tank pressures appear nominal. Battery voltages also appear nominal.
This is Delta Mission Control at T plus 27 minutes, 20 seconds. We're approaching main engine start in approximately 2 minutes.
Now passing 28 minutes into flight, a little over 1 minute remaining in the coast period. Less than 1 minute remaining until MES 2. Standing by for upper stage engine pre-start shortly. And we have pre-start on the RL-10. We have ignition and full thrust on the RL-10. This is the second of 3 planned burns for today's mission. This second burn should last approximately 3 minutes. Vehicle body rates have damped out nicely after initial startup transients. RL-10 engine operating parameters looking good. Now passing 30 minutes into flight.
This is Delta Mission Control at T plus 30 minutes, 8 seconds. As just reported, the RL-10 engine has been restarted. This second burn will last about 3 minutes. Our next event, MICO 2, completes the engine burns for this mission. Here again is Patrick Moore.
Now passing 30 minutes, 30 seconds into flight. Approximately 2 minutes remaining in the second burn. RL-10 operating parameters continue to remain nominal in the second burn. Vehicle body rates looking very good for this phase of flight. One minute, 23 seconds remaining in the second burn. Approximately 1 minute remaining in the burn. RL-10 continuing to perform well. Vehicle body rates remain stable. LOX and LH2 tank pressures also looking good, and ACS tank pressure also remaining stable. Standing by for MECO 2 in approximately 30 seconds. Approximately 10 seconds to MECO. And we have MECO. Upper stage engine is cut off. Vehicle body rates have damped out nicely from cut-off transients. We are now entering into an approximately 9-minute coast duration prior to spacecraft separation.
We've just heard confirmation of the successful cutoff of the RL-10 engine. The mission is now in a 9-minute coast phase, flying above Western Africa. Separation will occur over the southeast coast of Madagascar, approximately 50 degrees east longitude and 18 degrees south latitude. Welcome back, Lieutenant. It's time for us to now go through the trivia questions and answers, as well as to announce our winners.
All right, let's do it.
So question number 1 was, what was the first U.S. Air Force mission to ride on an Atlas V?
The answer is Space Test Program 1. Congratulations to @RocketAtlas5 for winning that trivia that round. On this mission in March 2007, 6 satellites were launched into low Earth orbit.
Question number 2 was, what was the first U.S. Air Force mission to launch on a Delta IV rocket?
The correct answer to that question is the Defense Satellite Communications System, also known as DISCUS. Congratulations to @PyroGoggles for being the first to correctly answer that question. DISCUS was first launched in March 2003 and is the legacy communication system to WGS.
Awesome. So question number 3 was, what was the world's first communication satellite and which organization operated this satellite?
And the answer is Signal Communications by Orbiting Relay Equipment, also known as SCORE, launched December 18, 1958 by the Air Force Ballistic Missile Division, which was the SMC predecessor organization. Congratulations to @BrandyDoesArt for winning this round. Also, something very interesting about this launch, the first transmission ever from space was from the SCORE broadcast, and it was a Christmas message from President Eisenhower.
That is really cool. So for our final trivia question, it was, for which U.S. Air Force program was the Delta II rocket developed?
And the answer is GPS. Congratulations to @PhilipTurtles1 for winning the final round.
That was a great game of trivia. Thanks to all of our participants. Congratulations to our winners. Congratulations also to the Air Force for their 70th anniversary. Here's a video by United Launch Alliance President and CEO Tori Bruno to commemorate the event.
American airmen have been breaking barriers since 1947 in air, space, and cyberspace. ULA's Atlas and Delta rockets have been a partner to the Air Force for much of that. Starting in the 1950s, when Atlas was developed as an intercontinental ballistic missile, and Thor, the predecessor of Delta, was an intermediate-range ballistic missile. Courageous airmen have refined the Air Force mission to fly, fight, and win through their blood and sacrifice, ensuring the unique contributions of air power will endure long into the future. And space is a critical part of their contributions. It's hard to imagine where our nation and the world would be without the capability provided by systems like DMSP, Advanced EHF, SIBRs, GPS, and WGS constellations. The U.S. Air Force has postured themselves to continue protecting, defending, and operating these critical national security space systems. The WGS-9 launch will commemorate the U.S. Air Force's 70th anniversary. We are honored to play a role in celebrating their accomplishments while safely delivering national security assets like WGS-9 to orbit.
We're now approaching spacecraft separation. Let's return to the mission.
This is Delta Flight Commentary at 38 minutes into the flight. Approximately 3.5 minutes remaining until spacecraft separation. Upper stage systems continuing to perform well during this coast. Helium bottle and ACS tank pressures remain stable. LOX and LH2 tank pressures remaining at expected levels. Vehicle body rates also remaining stable. Three minutes remaining until spacecraft SEP.
This is Delta Mission Control at T plus 39 minutes, 11 seconds. We're approaching spacecraft separation in just a few minutes.
Now 2 minutes remaining until spacecraft separation. Upper stage systems continuing to be performing well during the coast. Helium bottle and ACS tank pressures remaining stable. LOX and LH2 tank pressures remain at expected levels. Vehicle battery voltages also remain stable. One minute, 30 seconds remaining until spacecraft SEP. Now 1 minute remaining until spacecraft separation. Thirty seconds remaining until spacecraft separation. Vehicle body rates remaining stable. ACS thruster firings continuing as planned in preparation for spacecraft SEP. Standing by for spacecraft SEP shortly. And we have good indication of separation of the WGS-9 spacecraft.
Lieutenant, we just heard Patrick Moore report the successful spacecraft separation. Congratulations on the deployment of WGS-9.
Thank you, Mike. This is another important milestone for our warfighter, our nation, and our allies. I'm proud to be SMC and go wideband.
I'd also like to thank Patrick Moore for his participation in tonight's broadcast. For more information on this mission, please visit ulalaunch.com or follow us on Facebook and Twitter. We'll leave you now with another look at the liftoff of the Delta IV rocket carrying the Air Force's 9th WGS satellite. I'm Mike Underhill. On behalf of the entire launch team, thank you for joining us and have a great night. T-minus 10, 9, 8, 7, 6, 5, 4, RS-68A engine ignition, 1, And we have liftoff of the United Launch Alliance Delta IV rocket carrying the WGS-9 mission for the United States Air Force. What a great way to celebrate the Air Force's 70th birthday.
At full thrust. SRM burn profile is also looking good. 20 seconds into flight. SRM chamber pressure is beginning to tail off of max pressure. 30 seconds in.